In previous videos, we've covered the skill of algebraic long division. Now, it's a vital skill to be able to do, to be able to divide a high degree polynomial by a linear factor. It's something we want to be able to do, but as you noticed, it can be quite time consuming. We want a quicker technique sometimes that we can do it so that we can get through a question quite fast and quite quick. That's where this technique comes into play. What we're going to look at today is synthetic division, which is essentially a shorthand way of doing algebraic long division in a much more efficient manner. Now, the best way to demonstrate synthetic division is with an example. So let's imagine I've got 3x cubed plus 4x squared minus 3x plus 2, and I want to divide it by x plus 2. Alright, so let's imagine we've got this calculation. Now, I could lay it out in my step sum like I did for synthetic long division. Do my repetitive steps over and over and over again, but that could take a bit of time. What we're going to do is synthetic division allows us to do it quick. Now, when we're laying out synthetic division, we always lay it out the exact same way. First, we set up our table, which is quite simply set up like this. Then, we list the coefficients of each of the term in order of the powers along the top of our table. So in this case, I'd start with my x cubed coefficient, which is 3, then my x squared coefficient, which is 4, then my x, which is negative 3, and then my constant. So I'd have 3, 4, negative 3, 2 in this case. Once I've done that, the thing I want to look at is what I'm dividing by, so the divisor. And what I want to do is find the value that makes our divisor, in this case x plus 2, equal to 0. So in this case, I know that x is equal to negative 2. Once I've got this, that goes here on the outside of the table. Now, when you've got to this point and you've got all your values, you always start the same way. Your highest value here, you list underneath. Now, what you're going to do is we're going to move the values through, but each time we're going to do an operation. What we're going to do is we're going to take the 3 up and we're going to place it underneath the 4. But this line here, going back into the table, that means the same thing every time. It means that we're going to multiply the value we have here by whatever's outside the table. So whatever's going to take it back in. So in this case, this line always means multiply by negative 2. So I'll do 3 times negative 2 gives me negative 6. I then want to go back outside the table, so I then want to go down. But when you're going down, what you have to do this way is sum up the values in your column. So in this case, I want to sum up these values here. So 4 plus the negative 6. 4 plus negative 6 gives me negative 2. I then want to continue my steps and repeat it again. I want to take the negative 2 back into the table. And again, this line means the same thing. Multiply by the factor outside. So in this case, multiply by negative 2. The negative 2 times negative 2 gives me 4. And again, take it back outside the table. Now we're doing these steps over and over again, and we ultimately want to do it until we get outside the table underneath our final number. So we do negative 3 plus 4 to take it down, and that gives me 1. And I then take the 1 back up into my table again. And again, this line means the same thing, times it by negative 2. So I do 1 times negative 2, which gives me negative 2. I then go back down here, and I do 2 plus negative 2, so in this case that gives me 0. So at this point I can actually read off my answer. What I'm able to say at this point is 3x cubed plus 4x squared minus 3x plus 2 divided by x plus 2 equals, and you get your answer from here by looking at these as coefficients. But the only issue now is this has reduced in power. So it was a power of x cubed here. It's now become 1 less, so it's a power of x squared. This one here was an x squared, so its power's gone down by 1, so it's now an x. This here was x, its power's reduced, it's now just simply a constant. So we'd end up getting 3x squared minus 2x plus 1. Now, this value here at the end has a significance as well. This here's your remainder. Now, if we end up with a value here, we end up with a remainder. So if this was a 3, I'd have remainder 3 afterwards. However, this is equal to 0, so I've got no remainder. So this has 2 implications. One, it does have the implication of no remainder, but the other implication is, because I've divided by x plus 2 and ended up with nothing spare at the end, x plus 2 is a factor of 3x cubed plus 4x squared minus 3x plus 2. If we're ever asked to find or prove that a number is a factor, or do something with it being told it's a factor, i.e. find a coefficient which is maybe an unknown value, this is the key thing we're looking for, this being equal to 0. Let me show you an example of one where it's not. So let's imagine I'm now going to do 4x cubed plus x squared plus 2. Okay, now we'd start by laying out our table the exact same way. So to do synthetic division, we lay the table and we look at the coefficients. So coefficient of x cubed is 4, coefficient of x squared is 1. Now there's no x term, okay, but that doesn't mean we don't take it into account. We still have to. What we imagine is that in here there's a plus 0x. We imagine that that is what's hidden in there. And then we put a 0 in to represent the coefficient of the x. And then we do our constant. So any terms that are missing in terms of going down in our powers, we have to take them into account and put a 0 in their place. Now imagine then, I'm going to tell you, let's say we divide that by x minus 1. Again, once we've laid out our coefficients here, we do the same thing we did before. We say, right, what value makes x minus 1 equal to 0? X equals 1. That's now the value on the outside. And we start the same way. 4 goes down here. And we take it back into the table. And again, this line here represents the same thing. Multiply by the value outside here. So in this case, we multiply by 1. 4 times 1 is quite simply 4. We then take it back down outside the table and add up the column. 1 plus 4 gives me 5. Back into the table, 5 times 1 is 5. And then we go back out again. So 0 plus 5, that simply gives me 5 again. Back into the table for the last time, because we're at the last column now, times it by 1 and we get 5 there. We then go down the way and sum it up, and we get 2 plus 5 gives me 7. So, from this, I'm able to read off the answer to my calculation. What I'm able to say is 4x cubed plus x squared plus 2 divided by x minus 1 equals, and we read off our powers. But remember, this is an x cubed, this is now an x squared, this is an x squared, this is now an x. This was a constant, this was an x, this is now a constant, and this column here represents a remainder. So it's going to equal 4x squared plus 5x plus 5 with a remainder of 7 left. Okay. This means then that we can safely say x minus 1 is not a factor of this. So we have a remainder left over. So the basics of it are quite straightforward and simple. But like I say, it can have applications for finding unknown values. Let me show you what I mean. Let us imagine that I say to you, I have the equation x cubed minus 3x squared plus px plus 24. Okay. And p is just simply equal to an integer value. Now what I'm going to say to you is that x plus 3 is a factor. And imagine I then want to say find p. Okay, so x plus 3 is a factor of this and I want to find the value p. Well, we can use synthetic division to quickly and easily do it. So we can set up our table of values again, looking at the coefficients. So coefficient x cubed is 1, of x squared it's negative 3, our coefficient of x is our p, and our constant at the end is 24. So we've set up our table, and again, this is what we're dividing by. So in this case we say, right, so if x plus 3 is a factor, x plus 3 equals 0, so x is negative 3, and that's the value that's going to go outside our table. And we start the same way. So we start with our 1, take it back into the table, and it's going to be times by negative 3. 1 times negative 3 is negative 3. Add it up as we go down. Negative 3 plus negative 3 is negative 6. Take it back into the table, and we times it by negative 3. Negative 6 times negative 3 gives me 18. Go down and I add them up, but remember this is where we bring in the unknown value. So here I'd end up with p plus 18. Take it back to here, and again times it by negative 3, and I get negative 3 bracket p plus 18. go down and again add the whole thing up, and I get negative 3 bracket p plus 18 plus the 24. Now, this might not seem useful, but I'm told it's a factor and I want to find p. So I know that if it's a factor and I've divided through, the remainder I should have here is 0. So what I can do is state that that equals 0, and then solve it as a nice, simple little linear equation. So negative 3 bracket p plus 18 ends up being negative 24. Divide by negative 3 and I get p plus 18 is equal to 8. So from that, I know that p equals negative 10. So I've found my unknown value by remembering this. By remembering that using the synthetic division, this should be 0, and I've set up a nice little linear equation. Synthetic division, as I've said, exactly the same as algebraic long division. The only difference is it's much quicker. So if we're ever asked a question like this, this is probably the technique we want to stick with using.